Ms. Dietrich here. We're looking at a question that's actually a little more challenging than it first appears. Jason will use a 1/3 gallon pitcher to fill an empty 3/4 gallon water jug. How much water will he need in order to completely fill the water jug? So I thought I'd do this little image here to simulate what's going on. So we have this larger pitcher that we're going to fill, and we have these smaller little 1/3 gallon pitchers that we're going to pour in there. And they're basically asking us how many of these do we need to pour in here. So let's kind of visualize what we might do. If we take all of this and pour it in here and kind of partially fill this, so let's say we're filling it to there, we now have 1/3 of a gallon in the jug, right? Or 4/12. So let's just put that right here on the bottom. Now the whole thing is equal to 9/12. Is it full yet? No. We can add another one. So let's say we add another one in there. So that is poured in. And now how many 12ths more do we have? Well, we have 8/12, right? Because if we add 4/12 and 4/12, now we're up to 8/12. Now, can we fit the third one in there without it spilling over? And we can't, right? It's not going to fit. It's too much water. It'll spill over the edges. Now, another way that we might think of this, so we have 2 complete ones and we can fit a partial third one. Another way to think of this is really what we're doing is we're taking this value of 3/4 and we're dividing it into equal groups of 1/3. We're taking this pitcher and we want to know how many of these are equal to that. Well, if we do the algorithm for this, we keep the 3/4, we change this to multiply, and we flip this to its reciprocal. There's no pre-reduce. 3 times 3 is 9. 4 times 1 is 4. And now let's figure out what the mixed number equivalent is for that. 9 divided by 4 goes in twice with 1 left over. So we're looking at 2 1/4. So we can fit 2 complete ones, and then maybe we can fit 1/4 of this, like this amount of water. If we took that amount and poured it in there, then we'd be full. So let's look at the choices. Between 1 and 2 pitchers, well, we could fit more than 2, so that one's off the list. Between 2 and 3 pitchers, is between 2 and 3, is that what 2 1/4 is? That's a contender. About a half a full pitcher, that's not right, because look at, we could fit easily. This is a full pitcher, this is a full pitcher, so that one doesn't make any sense. About a quarter of a pitcher, that makes even less sense than C, because that's even a smaller amount. So that confirms it. Choice B is the correct answer.